Let's look at some more equations. Let's say if x plus iy equal to a plus ib by a minus ib, then prove that x square plus y square is equal to 1. We have to show this. Okay. Now, as usual, you take up, let's take the right hand side, a plus ib, a minus ib into conjugate by conjugate. See, the whole idea of multiplying by conjugate is that we want to remove the imaginary number from the denominator. That is the whole purpose. Okay, so a plus ib square, a square minus b square, a square minus b square, I square. So a plus ib, a square plus 2ib, 2aib, 2ab I plus I square b square by a square plus b square. Okay, now this becomes a square plus 2abi minus b square by a square b square. Okay, now let's split up the imaginary and real part. So a square minus b square by a square, here plus is there, a square plus b square plus 2ab by a square plus b square I. Now x minus iy is equal to a square minus b square by a square plus b square minus 2ab by a square plus b square I. Okay, so x square plus y square can be written as, remember, x plus iy, x minus iy, which is equal to x plus iy is what we have done till here. So that becomes a square minus b square, a square minus b square by a square plus b square and here it is square. So square here and square here plus 4a square b square by a square plus b square the whole square. Okay, now if we simplify it further, what do we get? A square plus b square the whole square divided by a square plus b square the whole square. So these two gets struck off and you're left with 1. Okay, now here there are many steps which are missing. If you do those steps, you will arrive at a square plus b square the whole square by a square plus b square the whole square. So here you will have to expand this, a square the whole square plus b square the whole square minus 2a square b square. Okay, let's do those steps as well to make sure that we are right. A square the whole square minus 2a square b square plus b square the whole square plus plus 4a square b square by a square plus b square the whole square is the LCM. Okay, now let's say a square the whole square plus 2a square b square plus b square the whole square by a square plus b square the whole square. So now if you notice on the top, previously it was a square minus b square the whole square. Now the same thing can be again rewritten as a square plus b square the whole square by a square plus b square the whole square. These two gets cancelled and you're left with 1, right? So a square plus 1. Okay, so we have shown. Now if you look at the left hand side, it is x square plus y square, and this is what we had to prove. Okay, now let's look at another and you might find this type of problems as well. Let's say you have 3 plus 2i sine theta by 1 minus 2i sine theta, and you have been asked to find the theta for which, right, for which this is a real number. That means the imaginary part is 0. Okay, as usual, multiply by conjugate by conjugate. Okay, so 1 plus 2i sine theta by 1 plus 2i sine theta. Okay, so distributive property, 3 plus 6i sine theta plus 2i sine theta plus 4i square sine square theta divided by 1 square minus 2i square sine square theta. Okay, so now this is equal to 3 plus 8i sine theta plus 4. Now that I square can become minus, I square makes it minus, so minus 4 sine square theta divided by 1 minus this should have become 2 square also, so 4, that I square makes it plus sine square theta. Now we can split it into real and imaginary part. So 3 minus 4 sine square theta by 1 plus 4 sine square theta plus 8i sine theta divided by 1 plus 4 sine square theta. Now here if you notice that it will be this whole thing would be a purely real number only if this is equal to 0, right? So let's equate it to 0 and see what happens. 8i sine theta by 1 plus 4 sine square theta equal to 0. Now let's take it to the other side. 8i sine theta, anything multiplied by 0 is 0. Okay, anything multiplied by 0 is 0. Let's take 8i also to that side, so anything 0 divided by anything is 0. So sine theta has to be 0 for this whole expression to be 0. Now for sine theta to be 0, theta has to be, again if you don't remember, cos theta is 1, so sine theta has to be 0, right? So here it is 0, that means opposite side is also 0, and in every half circle it is going to be 0. So this is pi, n pi, right? So we say n pi, where n belongs to integer. So the answer is that theta for every multiple of pi, this expression is purely a real number. Now if the question says for theta 2 pi, and okay, this is the condition it is attached. So in that case, instead of this general formula, theta will be equal to what? It can't be 0, since it says 0 is less than theta. There is no equal to sign. Pi, 2 pi is not included because equal to sign is not there. So theta has to be pi. Okay, let's do one more problem. 1 plus cos theta I divided by 1 minus 2 I cos theta. Now again, what we have to do is we have to find the value of theta for which it is a purely real number. Okay, as usual, let's multiply it with 2i cos theta, conjugate by conjugate. So this becomes 1 plus I cos theta the whole square divided by 1 square minus 2 square I square cos square theta. This becomes plus 2i cos theta plus I square cos square theta divided by 1 minus, because of this I square, this becomes plus 4 cos square theta, right? Now in the numerator, this becomes 1 plus 2i cos theta. Because of this I square, this becomes minus cos square theta divided by 1 plus 4 cos square theta. Okay, now let's split up this into real and imaginary part. So 1 minus cos square theta by 1 plus 4 cos square theta, and then plus, and then 2i cos theta by 1 plus 4 cos square theta. Now for this expression to be a pure real number, this expression, this term has to be equal to 0. So let us do that. 2i cos theta by 1 plus 4 cos square theta equal to 0. Now let's take the denominator to the other side, so that also becomes 0. Let's take 2y to the other side, that becomes 0. So cos theta is equal to 0 means theta is equal to, now we know that it is odd multiples of pi by 2. If there is a restriction on the theta, that it has to be between 2 pi and 0, then in that case theta would be equal to pi by 2 and 3 pi by 2. Okay, right? Theta should be between pi and minus pi. In that case, what will happen? Pi minus pi. So pi is this side, minus pi is this side. So what will it be? In that case, theta is equal to pi by 2 minus pi by 2. So depending on the restrictions, you have to specify the answer. I think that's enough for today. Bye for now.